Hello everyone and welcome back to Digital Nerds Conferences, Day 3. So for the time being, me and Catalin made a quick switch and I will be introducing our next guest speaker. So here with me I have engineering PhD candidate Madalina Blaj. So today with Madalina we're going to talk about resource efficiency based on the usage of additive manufacturing techniques in the aerospace industry. Quite a long name, quite a long title actually. So I'm waiting for us to break it down into parts and actually discuss what we have here. Welcome, Madalina.
Welcome, nice to meet you. Hi, everyone. My name is Blaj Madalina, and as Patricia introduced me, today I want to present you some information regarding the resource efficiency based on the usage of additive manufacturing techniques in the aerospace industry. Okay, and regarding this topic, I want to discuss about and to give some information about additive manufacturing. What is it? Where we are going to use it? Also, something about the product life cycle, also categories, and also advantages and disadvantages.
Dear guest, dear participant, we had a small technical issues, but those happen in this area, especially that we are new in this side of engineering, let's say. So please, Madalina, do continue from where you left. We are enthusiastically watching and waiting for you to give us all the information.
Okay, thank you. And I want to come back about the product life cycle. And here, initially, we can discuss about the raw material that we need to produce materials, the parts that we need with additive manufacturing. And after that, we need to pre-process the materials that we will need to create the parts. And after that, we need to focus about the printing process. And here we need to discuss about the steps of creating the parts. And here, initially, all of the techniques have the similar method of creating. So initially, we need to discuss about the digital model. And after that, we need to convert the digital model into a specific file. Most of the creators are using STL extension. After that, we need to pre-process, and after that, we will send the file that we've created, prepared with all the printing parameters to the additive manufacturing system. And in the end, if it's necessary, we need to perform also the post-processing. After that, we need to return to the printing process waste disposal, because in this case, we will have also material waste, but not so much like in the case of the traditional manufacturing methods. After that, we need to use the parts that we've printed, manufactured, and in the end, if we need to think about also the printing disposal. What we will do when the life cycle of a product is on its end. If we can extend the life product, or we need to recycle it. Okay, but here now I want to discuss also about the categories of additive manufacturing. And here I presented the most important categories, processes. And here I want to point out like inkjet, which is the first additive manufacturing method which was invented. After that, one of the most used additive manufacturing method, which is used in the aerospace industry, which is selective laser sinterizing or melting. And after that, one of the most affordable and which is most known 3D printing method, like extrusion free forming, widely known as FDM. And also the stereolithography, which offers one of the most detailed objects after printing. And here you can see also some examples like SLS for methyl on the left side, in the middle for FDM, and on the right side for SLS, for SLA with resin. Here I want to talk about also the advantages and disadvantages of additive manufacturing, because all the researchers are looking to find out new opportunities. The cost for these technologies, the trends is going to downfall. Also, we need to think about also the resources, and we need to take in consideration that we are going to save material and also energy. And also we need to think about also the prototyping cost, because the cost will be less. And also for small production, these kind of technologies are perfect, because we will obtain the products faster and less expensive. And we need to take in consideration also the inventory, because we don't need a large one. And also we can create parts with reliability. And also another one, it's a very important thing, that we can create parts with a very complex geometry that we cannot create in a traditional way. Also, I need to point out also the disadvantages, because nowadays, because these kind of technologies are going into the research form, we have limited materials, and the build size, the volume of the parts that are going to be used are restricted by the constructors. And also in some ways we need to make some post-processing. Another one, it's about the human resources, because in this way we need to tend to reduce the human resources, and this, I think, from my point of view, I think this is the main disadvantage. And here I want to say something about something about the most important manufacturing methods, and here about selective laser sinterizing. Here we can create metallic parts from with a raw material from powder, and we are going to create each cross section of a part after the laser is going to pass and to melt the material into a certain way, in our desired way. After the first layer is finished, we are going to add more powder, more raw material with a roller, and after that we are going to repeat the process until we will obtain the final part. Another one, this method is fused deposition modeling. This one is one of the most used method of 3D printing, and in this way we are going to use raw material with each and its form it's into a wire, and we are going to add that material into a heat treated room, and that material is going to be melted, and with the help of the numerical command we are going to add material into a desired cross section until we will obtain the final part. I'm going to say something about the stereolithography, and with the help of a light source, we are going to cure the liquid resin into a hardened plastic until we will obtain the final part. And here I want to give some comparison between these methods. As I've said before, the FDM method is one of the most affordable method, and it's the best usage for it. It's for simple prototyping. And for SLA, it's about the materials, because we will obtain the highest resolution and accuracy and the fine details. And this one is the best especially for molds. And if you have a passion or a hobby to create aerospace modeling, if you want. Okay, and another one, it's another method, it's about the SLS, and here we will obtain the highest productivity and with excellent mechanical properties, because in this way we are going to obtain an isotropic material compared to FDM, where we will obtain exactly the opposite, where it's anisotropic. And this means that we will have different mechanical properties in different sides of the part. And this one is the best for functional prototyping and end-of-use production. Okay, and here, because I've said that the metallic additive manufacturing is one of the most used, the metal industry occupies and offers 12% from the global carbon dioxide emissions. And that's why the researchers think about the resource efficiency and also to create something sustainable manufacturing. And additive manufacturing with all the techniques implies all these conditions. Okay, and in this way, we need to think also, I'm going to split this in 4 fields. And initially, we need to think about the product design. After that, we need to discuss about materials. After that, the processes. And in the end, about the end of life. Okay, and about this. If we are going to discuss about product design, here it's the best example. In the first image, we have a bracket from Airbus 350 XWVB, and it was the first part introduced for a serial aircraft ever in 2012. And we can see here, I think is the best comparison because the above part, it's created through conventional technologies, and the other one is obtained through additive manufacturing as SLS method. Okay, and as we can see, we are going to obtain a lighter part, and as far we know, the mass reduction is very important in the aerospace industry, and because for example, with 1 kilograms a lighter aircraft, we are going to save a lot of fuel. And this technology offers also a reduced material waste, because we are going to add material not to take away material from a block. And this implies also lower costs and also a reduced assembly time. And when I'm referring to a reduced assembly time, for example, on the right photo, we can see an assembly which implies 3 parts. And after redesign and optimization, we are going to use only 1 part. And another example, it's about another bracket. And the initial one, which was obtained through traditional technologies, its mass was about 2 kilograms. But after optimization, it was under 1 kilogram. And as I've said before, with this technology, we can obtain very complex geometry. And this can be seen also here in the middle, because if we can perform such creation in conventional technologies, it will take too much time to create it. But with this kind of technology, we can build it very, very fast. And this is one of the main advantages. Okay. And if I'm going to discuss about materials, also I'm referring to metallic materials. Here I need to remind about the titanium alloys, also aluminum, and also about nickel. And nowadays metal powder production still needs some further studies, but because this needs embodied energy requirements. But the researchers tend to use on-site manufacturing technologies, especially for space exploration activities. And they want to, nowadays there is such a laboratory on the International Space Station. And here it's an astronaut who is showing us a part which was created there above us. Okay, but the tendency, it's also reminded by European Space Agency. And they also started a competition for children and it's called Moon Camp, and they want to send a spacecraft there and to create a moon camp there. And we know that the lunar soil, the moon soil, has a lot of resources, and we can use it for 3D printing. Okay. And when we are talking about the processes, we need to think especially for manufacturing parameters. And here, we need to make an optimization in order to obtain and to maximize the mechanical properties. And this one it's also my main research topic for my thesis. And here, if I want to discuss, for example, I want to offer an example for FDM method. If I'm going to add a part into Z direction, I will obtain the worst material mechanical properties. But if I'm going to add and to put the part through since the design direction from the design phase, I'm going to maximize the parameters because we are going to obtain the best mechanical properties when we are going to put the part into the printing direction. And the process, it's not only about how we are going to control the design parameters, it's also about the environment and also about process and also about human resources, because we need to take in consideration also about the experience of everyone who is using these technologies. And in the end, for the fourth side, I need to take in consideration also the end of life and also to discuss about circular economy. And here we can consider custom-made repairing. And for example, here I have an engine blade which suffered something, an incident, and after a disassembly, cleaning, inspection, the engineers made a restoration, and after that they made a reassembly, and in the end the testing. And we can perform also on-demand production spare components. And if we are going to discuss about something about circular economy, we can discuss about how we are going to recycle metals and plastics, especially powders and wires, after the usage of these technologies. But also I need to remind also about the regulators and the regulations. In Europe, we have European Aviation Safety Agency, and in the United States, we have Federal Aviation Administration. And all the airplanes and all the helicopters and everything, it's going to be produced considering these regulations. And after they've seen the amount of interest for these technologies, they started to provide guidance regarding these technologies, and in order to avoid some negative events. Okay, and in this way, they started to make some regulation for aircrafts, for different kind of products like aircrafts, rotorcrafts, and propulsions. Okay, and conclusions. Here is that airplane that I've said before, Airbus 350. Okay, and here one of the most important conclusion is that we have one of the most advanced production process, and it offers industrial sustainability and the capability to rewrite the manufacturing rules. And this offers also the possibility of scaling and the adaptability possibility. And one of the most resource usage is that we are going to limit the material usage. And also it offers new research fields, because these additive manufacturing methods are not going to be used only for aerospace fields. We can use it also for medicine and also in the food industry, in a lot of fields. Okay, and I want to thank you for your attention.
Thank you, Madalina. I must admit, I really enjoyed your presentation, especially that for me and probably most of our viewers, we are new in this area, so everything was new and excited to learn. So I do have a couple questions.
Okay.
So you did mention the SLS, LSA, and FDM, which are your additive manufacturing techniques. And I wanted to ask you, from your experience, from what you've seen so far, what are some of the most interesting parts that you've seen built using these techniques? Some of the most interesting. Why are they complicated? What are the advantages? What were the complications? So everything you think might be interesting for our users, for our participants, to see and to know about these parts and about their manufacturing techniques?
Okay, this one I'm going to say especially for VDM method because this one is my main research field. And here I want to say that on the beginning I started to learn by myself. I have a 3D printer at home. And after that I started also to work on the university. And it was quite interesting because on the beginning I didn't know exactly how to manage because each material producer has its parameters and I need to find the perfect combination for me in order to obtain the perfect part, because initially I need to, okay, I have these parameters, I need to obtain the perfect mechanical properties after initially a visual inspection, and in the end I was using also a microscopic view, and it was very interesting. But as I've read also in the specialized literature, I've encountered the same issues like other researchers, like that we don't have, we need to find a perfect combination for manufacturing parameters to maximize its usage for mechanical parameters, because else we cannot use it in for a daily usage. I'm referring here for structural parts, not for decorations or something else.
To what extent do you believe that maybe teenagers and kids have access to this area of engineering to learn by themselves? Do you think they have enough resources and informations on the internet, in the literature to learn by themselves?
I think yes, because I've seen not only, I'm going out from the academic field, and I've seen that also on the social media, a lot of people are interested on this field. And especially for VDM method, we are not supposed to know design method, and we can use that 3D pen. I hope that some of the people knows about it. And kids, it's a very good start to work with that one.
What do you think? So, for the people that haven't started yet doing 3D printing, what do you think might be the advantages? What can you learn? What are the learning outcomes you can take from this area, from 3D printing, from everything from learning how to do computer-aided design to actually getting the part that you want? What do you think are the advantages of having this learning process?
I think they have a better view of this process, but if they are very interested, they can discuss with someone who has some knowledge about this, and because it's a smoother path for them, and in this way they can. And also another big question for them, it's what they want to do with this technology, because as I've said, we can use it for a lot of fields.
From your point of view, what do you think is maybe one of the most interesting and intricate projects that were done using this type of technologies? From your perspective,
okay.
Or what do you think is one of, what would you like to explore, if like just theoretically, if there's nothing out there?
Okay, I've seen, I think 1 month ago, the European Space Agency just started a collaboration with a company from Germany, who started to make additive manufacturing for metallic parts for the rocket. And I think it's quite interesting. And I want to find out more about this topic. And I found this very interesting, especially for me, even if the technology of additive manufacturing is quite different. Yes, about what I'm doing for my thesis.
Thank you, Madalina.
Thank
we
you.
love talking with you. We have definitely learned a lot of new things. And for the rest of you, please continue watching. We'll have a small break, a short break, so we can have a bit of a rest and until we get our next speaker ready. And stay tuned to find out more.
Okay.